Welcome to The Explainer. Today we're going to unpack a word that has absolutely defined the last few years for all of us: coronavirus.
You know, we've all heard the name coronavirus countless times, especially since 2019. It just brings up so much, right? But the thing is, the story of this virus family, it didn't just start a few years ago. So, to really get a handle on what happened, and maybe more importantly, what could be coming next, we've got to look past the 24/7 news cycle. We need to get down to basics and understand the virus itself. Okay, so let's dive in. What exactly is a coronavirus? All right, first things first. Let's unmask this familiar foe. What are we really talking about when we say coronavirus?
So right off the bat, these viruses aren't new. Not at all. Scientists actually first pinned them down way back in the 1960s. They're part of this huge family of what are called RNA viruses. And all you really need to know about that is their genetic material is super flexible, which means they can change and mutate really fast. And that name, corona? Well, it's Latin for crown, because if you look at them under a microscope, they have these spike proteins sticking out that look just like a crown.
Now, most coronaviruses, they just give you a common cold. Annoying, but not world-stopping. But there are three members of this family that have really shaken the world in the 21st century. Three that made the jump from animals to humans and caused massive global crises. And when you lay it out like this, you start to see a pretty unsettling pattern, don't you? First, in 2002, we get SARS. Then, almost exactly a decade later, in 2012, MERS pops up. And then, right on schedule, at the end of 2019, SARS-CoV-2. It's like clockwork, a new, dangerous coronavirus making its debut roughly every 10 years.
Okay, now this is where it gets really interesting. Look at the huge difference in how deadly these viruses are. MERS? Wow, a case fatality rate of over 34%. That's just staggering. It was incredibly lethal. The saving grace? It didn't spread very easily between people. You needed really close contact. Then you have SARS at just under 10%. And then COVID-19, which, for all its global devastation, was actually much less fatal for each person who got infected.
And this chart? This right here explains everything. It shows us exactly why COVID-19 exploded into a pandemic. First, look at that R0 number. That's just the average number of people one sick person will infect. For COVID-19, it was pretty high, kind of like the original SARS. But here's the game changer, the absolute perfect storm. You combine that high R0 with significant asymptomatic spread. That means people were walking around feeling perfectly fine but spreading the virus. And that made it nearly impossible to stop. Okay, so we know they can be incredibly dangerous. But how does this all start? How does a virus that's supposed to be in an animal suddenly end up in us? And once it's in, what's its plan of attack? Right. The key thing to remember is that these aren't human diseases to begin with. They start out in animals, bats, camels, civet cats, that kind of thing. But then, at some point, the virus mutates just right and it makes a leap, a spillover event into humans. That whole process has a name, zoonosis. And it's the starting pistol for every single one of these outbreaks.
So picture this. The virus is like a tiny burglar, and it has a special key. Remember those crown-like spike proteins we talked about? Well, that's the key, and it's perfectly shaped to fit into a specific lock on our own cells, a receptor called ACE2. Once that spike protein key slides into the ACE2 lock, click, the door to our cells swings wide open, and the virus lets itself in.
And once it's inside, the plan is brutally simple and efficient. It attaches, gets its genetic material inside, and then it pulls off a hostile takeover. It hijacks our cell's machinery, turning it into its own personal virus factory. The cell is forced to churn out thousands and thousands of new virus copies. And then they burst out, ready to invade more cells and repeat the whole cycle. It's pretty relentless.
Okay, that's the viral invasion plan. It's scary stuff, but we're not defenseless. So how have we, as humans, learned to fight back? What's in our playbook?
Let's start with two words we all got very familiar with: quarantine and isolation. They sound almost the same, right? But they're for two totally different situations. Quarantine is for people who were exposed to the virus. They might not be sick yet, but we keep them separate just in case. It's about preventing a fire before it even starts. Isolation, on the other hand, is for people we know are sick. That's about boxing in a fire that's already burning to stop it from spreading. But here's the thing.
There's no one single thing, no magic bullet that stops a virus like this. The whole public health strategy is based on a layered defense. You might have heard it called the Swiss cheese model. Think about it. Every single measure, whether it's washing your hands, wearing a mask, social distancing, or even a vaccine, every layer has holes in it, just like a slice of Swiss cheese. But when you stack all those slices together, the holes don't line up, and you create a really solid barrier.
And that brings us to one of the most powerful layers, vaccines. What's the end game there? Well, it's to hit a magic number, something like this, over 70%. That's the ballpark for what's called herd immunity. It's the point where so many people in a population are immune that the virus just kind of runs out of places to go. It can't find new people to infect, and the chains of transmission just fizzle out.
So looking back, the COVID-19 pandemic was, well, it was a brutal worldwide stress test, wasn't it? It definitely showed us some of our strengths, but more importantly, it put a giant spotlight on some really critical weaknesses in how prepared we are as a planet for something like this.
And the big lesson, the thing that experts all over the world keep coming back to, is this. Working together isn't just a nice idea. It's not optional. Things like global surveillance systems to spot the next threat early on, having rapid response plans ready to go, and real, genuine international cooperation, these are absolutely essential. In a pandemic, you're truly only as strong as your weakest link.
And if we want to stop the next spillover from happening, we can't just think about human medicine. We have to think bigger. There's this idea called the One Health approach, and it's simple, really. It recognizes that the health of people, the health of animals, and the health of our planet are all deeply, deeply connected. You can't separate them. So, protecting ecosystems and keeping an eye on animal health, that's a critical part of preventing the next human pandemic.
And that's the question we're left with, isn't it? Because the viral playbook doesn't change, but ours has to. The last pandemic taught us some painful lessons. But given that pattern of a new threat emerging roughly every decade, the question isn't if there will be a next one, but when. Are we ready for it? Thank you for joining this explainer.